Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC 12 Problem of the Week video, and this one is about tangent circles and also writing and solving quadratic equations. So without further ado, let's get on with the video. This is AMC 12A Problem 16 from the year 2009. A circle with center C is tangent to the positive x and y axis and externally tangent to the circle centered at 3, 0 with a radius of 1. What is the sum of all possible radii of the circle with center C? And here are your answer choices. So the key words here are that there is a circle with center C, and this is going to be tangent to the positive x and y axis. And it is also externally tangent to a circle that has a center of 3, 0 and a radius of 1. And it is asking you what is the sum of all the possible radii of the circle with center C, which is the first circle we're talking about here. So the first thing we're going to do is draw ourselves a diagram so we can see what it is talking about. So here is the circle with center of 3, 0, and then we are going to have a circle here that is tangent to the x-axis and the y-axis, and it is also externally tangent to the circle. And then we're going to have another circle that is going to be really big and tangent to the x-axis and y-axis. That is not the best diagram, but you get the point, with a center right here. And these are going to be the circles with center C, so we're going to name it C1 and C2. Now, it is asking you to find the sum of all the possible radii. And so we know right here, this is going to be where it is tangent to the y-axis. So this, we're going to label it R. And then right here, if we go down, it's also going to be tangent to the x-axis. And this is also going to be R. And if we connect this with the center of 3, 0, we know that this is R and then this is 1. So the total right here is going to be R plus 1. And we know that this is 3 right here. So if we list an equation, we can solve this. So how are we going to solve this? Well, we know that this point right here is going to be R, and then this is going to be 3, 0. So how do we find the length of C2 to this 3, 0 right here? Well, it is going to be the square root of x1 minus x2 squared plus y1 minus y2 squared. And this length right here, we also know that it is going to be equal to r plus 1. And then this is going to be the quadratic that we get from this. And so we can tell that if this is a quadratic, it is going to have two solutions. And since there are two circles right here, we need to find the sum of the radius of these two circles. So we know that the sum of the two roots here are going to be the sum of the two radius here. And the sum of the two roots here is going to be negative b over a. So it's going to be 8 over 1, which is going to be equal to 8. And that is going to be your answer. Looking at the answer choices, we can see that the answer is going to be D, 8.